Okay, so the first thing I was saying is what you have to do is you have to split the difference of the singular quadratic centered trinomial, and then at that point you need to square root the secondary radical that... Actually, if the quadratic is in intercept form, all you gotta do is find the x-intercepts and split the middle. It's gonna be a good video. Yeah, it's gonna be a good video. That's what we gotta do, man. It's kind of, maybe in a way, it's a two-step process. We find those intercepts and we split the middle thanks to the beautiful symmetry of the parabola. We're gonna have a good time on this video, but before we begin, I got a question for you. What's your bright spot today? All right. My bright spot today are those advent calendars. I'm recording this in December. We got one for my son, and it's Thomas the Train. Man, may we all wake up as excited as him when he knows he's going to get a new train. Man, may we all wake up as excited as he is. All right, let's go get after it. All right, so here's our first example we're going to do. We have this quadratic equation, right? It's quadratic because we're going to get x times x, which is going to give us x squared. It's in intercept form, which I've written there in purple. So the question is going to be find the vertex. So maybe I should write that. Okay, so what we're going to do is first find those x-intercepts, which you could do using mathematical structure. So if we look to here, the p-value must be 2, right? So that's the p-value, that's the q-value. So our x-intercepts are going to be at, I'll put it here, they're going to be at 2, 0, and 6, 0. So let's graph them. All right, so the thing to also note about a parabola is it's perfectly symmetric. It is so beautifully symmetric. It is like, Lord, you are symmetric. So if you've got 2 points that are on the same horizontal line, the vertex, which is the center, right, has got to be in the middle of those 2 points. So it's got to be here. Let me switch to red. It's got to be here, which is called like the line of symmetry or the axis of symmetry. So we've got to figure out where that is. Here's my advice to you. What I like to do, or what I tell students to do, I just say, look, if you're going to go from 2 to 6, you got to add 4. So that means halfway has got to be to add 2. I mean, you could figure out how you want to find the center. That's up to you. But you got to find the center. So we know the center must be when x is equal to 4. So let me write that here. And then the question then, because essentially where I'll put the answer here, let's go to green. This is going to be our solution. So the vertex. So what I know now is it happens at 4, but I don't know the y value because a vertex is 2 coordinates. It's an x and it's a y. But that's the beauty of an equation. That's what an equation gives you. It tells you the y value for any given x. So if you know x equals 4 is the one we're interested in, go back to that equation and plug in 4. Yeah, there you go. That's how we do it. So now we got to evaluate this equation. So let's just keep going. Y is equal to 2 times negative 2. You still with me? All right, here we go. Y is equal to negative 4. Gorgeous! Oh, let the heavens open up. So when x is 4, y is negative 4. That's the vertex. Done. So what is it? Here we go down 1, 2, 3, 4. I mean, you know, it's a little sloppy because it's on a whiteboard, not perfect, but good enough. And if you wanted to graph it, you could draw it. Beautiful. Let's try another example. All right, let's get started. Hey, when I started this video, I said there's 2 things you got to do to find the vertex. You got to find the x-intercepts, and then you split the middle, and there's the vertex right there for you. So let's do that first step, finding the x-intercepts. Why don't you hit pause and beat me to it? Pause. Unpause. All right. Well, if you use mathematical structure, right, like is implied in this cloud up here, the p-value must be 5, right? That's p. P's going to be 5. And then that would be the q value. But q is, the structure is a subtraction. So if we're seeing an addition, that must mean we're minusing a negative. So in this case, q is, I was going to write -5 for some reason, but q is -1. And so our two x-intercepts, I'll put them back where I put the last two, are going to be at 5, 0 and -1, 0. By the way, if you forget about mathematical structure, that's cool. Just remember that x-intercepts are always, Mr. Miller, always. They're always the value of x that makes y 0. Right, so you could just set it up like that and say, okay, well, when x is 5, that's 0. 0 times 6 would be 0. And when x is -1, that would be 0. And 0 times -6 is 0. So even if you forget mathematical structure, and by the way, I do have other videos that might be go into more detail on that, but hopefully you're staying with me. Let's keep going. All right. So here we go. Drew my quick XY axis there. Let's graph where they are. So I'm going to go 1, 2, 3, 4, 5. I'm going to put 5 right there. That's one of my intercepts. And the other one's about right there. Okay, so those 2 points lie on the parabola. There's this U shape happening here. And these 2 points are on it. And so the vertex has got to be in the center. So we found the x-intercepts. Now let's split the middle. However you want to do it. How I'm going to kind of show you is I'm thinking in my head, if I take 6 steps, I'm at the other side, right? So if 6 steps gets me on the other side, then 3 steps got to have me in the middle. That's right. That's right, Mr. Miller. All right, here we go. Just draw that line. That's going to be x is equal to -1 plus 3, right? So x is equal to 2. So I know that's, here, vocabulary throwdown. What's that line called? Yes! It's called line of symmetry, or the axis of symmetry. Oh, hey, whatever you want to call it. Whatever floats your boat, as we used to say. All right, so now what we're going to do is we're going to take that number 2, and we know, let me go back over here to our solution. We know this. We know the vertex occurs when x is at 2. And so let's figure out the y value. Let's take that 2, plug it back into the equation. Gorgeous, gorgeous. I'm liking this. It's a beautiful structure. Intercept form. Man, you give me equations in intercept form, you got a happy man. I tell you that much. All right, so we're at -3. 3 is equal to -9. That's a beautiful thing. So, it's way down there somewhere at 2, -9. I'll go over here, write the answer. And that's it. If you want to graph it, you could just draw it in right now. All right? Okay. Well, we're going to do one more example because I want you to think to yourself, okay, Mr. Miller, we good. I feel this, but can it get more complicated? I think this next example is maybe how we achieve a little bit more complicated. Let's see. Follow me. All right, let's get it. So why did I say more complicated? Is because there's an a value that's not 1. Right? The a value in my previous 2 examples was 1. Now it's -2. I did still set you up to where the axis of symmetry is going to be at an integer, so maybe I could have made that a decimal, but let's just do this problem. It's a beautiful problem. All right, it's 2 steps. What are they? The 2 steps are find the So it's interesting, if you use mathematical structure, this says it doesn't matter what the hell A is. It says no matter what that number is, I mean, it could be anything. The intercepts are still at P and Q. So I'm going to look to here and say, well, I still know that P is -4, right, because of the plus. And I know the Q value is at -10. So we could just jump right to our intercepts. There they are in all of their glory. Because at the end of the day, I mean, the value, where did that black marker go? Where did it go? Okay. Look, the value of x that's going to make y 0, this does not matter. Because if I make x -4, like I take that one. So I plug that in, that becomes 0. If I plug in -4, that becomes 6. That's a true equation. 0 times anything is 0. So this is totally irrelevant in finding the intercepts. But it's going to play a point in finding the vertex. So let's finish the story. All right. Looking at the clock. Bell rings in 6 minutes. If that bell rings and I'm still making this damn video, I know I took too long. I know I took too long. I don't need that much time for this. Let's see. All right, so I'm going to go -4 here. I'm just going to put -10 there. All right, those are my two intercepts. So let me split the middle. I'm just thinking to myself, if I'm at -10 and I want to count to -4, I got to add 6. So there, if I add 3, I must be in the center, right? If I add 3, I must be in the center. So try to get that as close to the center as possible. -10 plus 3 would be -7. So we would have x at -7. Let's update our little answer box over here. We now know the vertex is located at -7. To find the y value, let's plug -7 back in. So I'm going to go here and kind of just do it. I'm going to take advantage of having a whiteboard. I'm just going to erase the x value and put -7. All right. Well, we're almost there. We are. All right, so I'm going to go to here, use this little space. So we got y is equal to -2, right? There's that value, times, that's -3 times +3. So here's really the only difference is when you're calculating the vertex, you have to take into consideration that you've got to multiply by -2. Well, let's just do it. I'm going to go -2. I'm going to first multiply these two values and get -9. And now I'll multiply them both together and get 18. And we're done. And also keep in mind, when the a value is negative, right? A negative a value means the parabola goes down like that. It points down. So the vertex has to be up here if it's going to point down. So we're actually stoked that that's a positive number. We are stoked. Well, I hope we're stoked, and I hope your life is treating you well. I hope this video was helpful. Thank you for being here today. May the rest of the day treat you kindly, all right? Stay hip. Take care.